Hi, and welcome to Mr. Hamilton's Math Bites. This video is about the inverse of a quadratic function. So today there are a number of goals, and I highlight them specifically because there are such a number of them, and they may not be intuitively obvious right away. The first one is determine and describe what an inverse function does to the original function. Then we want to graph both functions and their inverses and make connections between these graphs. We want to determine the relationship between the domain and range of a function and the inverse. We want to use the function notation of an inverse, and we want to determine if a function or its inverse are functions or non-functions. This is a good thing to come back to at the end of the lesson to make sure, as a checklist, you know how to do these, because right now it may seem a little bit overwhelming or you might not understand the terminology, but I promise you will when you're done this lesson. First off, what is an inverse function? An inverse function is a function that undoes what the original function did. So for example, just think about if I dig a hole, well, how do you undo digging the hole? Well, it's filling the hole back in. So it's the opposite operation, but mathematically speaking. In other words, the inverse maps values in the range of the original function back to values in the domain of the original function. And there's an intro to function inverses video on the website if you have more questions about that. So for example, the function f of x equals 2x minus 6 has an inverse of f inverse x. That negative 1 doesn't mean anything wonky except that it means inverse. It doesn't mean the power of negative 1. That's equal to 1/2 x plus 3. Graph these two functions on the grid provided. So 2x minus 6. We recognize this is a linear relationship. So I start at negative 6 and I have a slope of 2, so I go up 1 over 2, up 1 over 2. I do a number of those points. Oops. And then I can draw the line of best fit through those points. Might not be perfect, but that's pretty close. Now we have this other function, f inverse of x is 1/2 x plus 3. Again, don't worry about that negative 1, just treat it like a function. Treat it as a function. So let's do that. Let's pretend that we're just graphing f of x equals 1/2 x plus 3, because f inverse of x, that's the same idea. We graph it like a function. So we start at finding 3. And then what we do is we take a slope of 1/2 now. So I'm going down 1 over 1. Down 1 over 1. Down 1 over 2, rather. Down over 2. And I continue that until I have enough points to draw a nice line of best fit through. This linear line through them. I'll move that down a bit. Hopefully line it up pretty well. That's pretty close. Okay, so now, how do those two functions compare? That's what we're interested in here. We have the function fx, f inverse of x, is equal to 1/2 x plus 3. That's the less steep function. And the more steep function is f of x is 2x minus 6. Well, I hope you've noticed a specific line here. I'm going to draw this in a different color. That, interestingly enough, seems to reflect those two lines about it. Right there. This is the line y equals x. Right? It's a simple diagonal line. And I hope you'll notice that these are exactly reflected, these two lines, about the line y equals x. So how do these two inverse functions compare? Well, the one line is a reflection of the other about the line y equals x. So what's really happened is the x and y values have swapped. For example, if that doesn't become intuitively obvious to you yet, if we look at the function f of x, when x was 0, well, what was the y value? When x was 0, the y value was 3. And in the function f inverse of x, when x was 3, hey, the y value was 0. And you could do that for any given points. We could take the point 4, 2 right there, and the other function, it's the point 2, 4. We have those x and y values swapped. So we've determined that on a graph, it reflects about the line y equals x. We've determined that it switches the x and y values. But we've also mentioned the fact that what it does is it actually does the opposite operations. So here are a couple of questions dealing with linear relationships where we're trying to find the inverse of a function. How do we apply these opposite operations? Well, here's how we do that. Well, what's happened here? Well, we've multiplied by 1/3, and then we've added 7. Well, if we want to do the opposite operations, we have to do the opposite operations to these in the reverse order. So we have to first subtract 7, and then multiply by positive 3. So again, the f of x was multiplying by 1/3 and adding 7. And then the opposite operations for the f inverse of x is going to involve subtracting 7 first and then multiplying by 3. So let's see how this is actually done formally. It doesn't just mean we write f inverse of x is negative 7 plus 3x. That's not what we do. Here's what we do. We first let y equal f of x. So that means that y is equal to 1/3 x plus 7. Then we switch x and y. Like we saw in the graph above, the x and y values switched. So we do that. Now, what we need to do is rearrange for y. So I'm going to get x minus 7. There's that subtracting 7 first, and then it's equal to 1/3 y. Now to get y by itself, I need to multiply by 3, and there's that second step in that inverse portion. So I'm going to get 3 times x minus 7 equals y. Multiply both sides of that equation by 3, and the 1/3 is going to multiply by 3 to give us just 1y. Well, expanding this out, we get 3x minus 21, and that is what y is. Well, let's write that in actual inverse function notation. F inverse of x is equal to 3x minus 21. So that is how you find an inverse function. So give that a try for part B and check your answer with me. So here all we have to do is we start by letting y equals f of x. So we get y equals negative 2x minus 14. Then we switch x and y. So we get x equals negative 2y minus 14. Then we rearrange for y, or solve for y. So we get x plus 14 is equal to negative 2y. Dividing both sides by negative 2 gets me negative 1/2 x, because there's like a 1 in front of that x. That's how I get the negative 1/2. And then minus 7, 14 over negative 2 is negative 7, is equal to y. So that means that the second example here, f inverse of x, is negative 1/2 x minus 7. And that is how you find the inverse. And we'll do more tomorrow in class with an investigation, and we'll learn about how to find the domain and range as well. And also, obviously, how to find not only the inverse for a linear function, but how to find it for a quadratic function.